Hey everyone, we are going to be working on page 7 today. So we just finished our atmosphere one on page 5. Today we're going to be working on humidity. So we'll write in humidity on page 7 in our table of contents, which is our page 1. And so page 7, I'll go to that one. So page 3 is our water cycle. Page 5 is our atmosphere. And so now we'll have page 7. So to begin with, I'll put page 7 down here on the bottom right. And then we need to set this up for Cornell Notes. So let's put our line down the side and 2 lines across the top. So our page is set up. Put my name on the top. So if you lose your notes, I know who to give them to. Is the 9th, and then put what period you have science. So again, we're talking about humidity today. So humidity, let's go ahead and put that up here. Humidity. And the question we're going to ask, the essential question, what else affects cloud formation? What else affects cloud formation? Because there's a lot of stuff, and we covered a few things on the last page, like air pressure and altitude and wind, and then like condensation and precipitation. Those are really good things, but we're going to get a little bit more specific now. So the first thing I want to talk about is dewpoint. And if you guys have ever watched the news, they're going to use a lot of these terms in there. And so this will help to be more familiar with that. Dewpoint. So I'm going to underline that, put my dash. Remember, that's my imaginary line that I don't cross with my definition. So the definition of dewpoint. The dewpoint is the temperature at which condensation begins. So that's when it starts. Now, if you remember from before, condensation is when air, gas, like water vapor, turns back into liquid water. So gas water turn into liquid water. So that's condensation, and dew point is that temperature where that happens. So the air can hold so much water, only so much water, and if it's hotter, like hot air, that can actually hold a lot more water. But as it starts to cool down, that air can't hold as much water, so it starts to condense out. It does need something to grab onto. It does need a surface. So let's put in there, needs a surface to form on, and depends on temperature. Obviously, it's in the name, but so yeah, that's dew point. So that's the temperature that condensation begins. It needs a surface to form on. It depends on temperature. And if it's below freezing, it's going to form frost instead of bubbles. Not bubbles, dew. So if it's below freezing, it's going to equal frost. So that's the dew point. So at some point, the air is warm, it collects this air water vapor, and then as it cools down again, it hits this temperature, specific temperature, where it's going to start forming water on a surface. And if that temperature happens to be below freezing, then it's going to end up as frost. So that's kind of cool. That's the for clouds as well. So if it's up in the atmosphere, it needs this surface to form on. So that'll be dust or other like smoke particles in the air. And if it gets cold enough, it starts to form like ice crystals and stuff up in the air, and then we'll get snow. Or if it builds up even more, we'll get rain. So that's dew point. The next thing we need to talk about is humidity. And I'm sure you've heard, oh, it's really humid out. Or it's so humid out you can feel the air. Yes. So the humidity, it's the measure of how much water there is in the air. Measure of water vapor. In the air. And again, this depends on temperature, so let's put that. Depends on temp. So if I say a higher temperature is going to equal more water vapor. So a higher temperature, more water vapor. A lower temperature is not going to hold as much water vapor. And there's a way that it's going to be more commonly talked about, because you could say, oh, it's humid, but what does that mean? Like, obviously there's going to be water vapor in the air, but how does that affect us? So most of the time it's talked about as a relative humidity. Relative humidity. All right, so relative humidity is the percent. So this is just the measure. This is the percent water vapor in the air. So that percentage is even more, I guess, dependent on this temperature, because it tells us more about it. So we're going to pretend like we have a box. Okay, let's say it's warm. It's warm outside. And let's say that we have 50% humidity. So that means that for how much air, for let's say this amount of air, it can hold 10 grams of water. So it can hold that much water, whatever. Cold air can only hold this much. So if I have that same amount, it's not 50% anymore, it's 100%. And so if it's warm out and I have, let's say, 8 grams of water in the air, it's not going to be as bad. But if I have 8 grams and it fills the air because it's cold and that's as much as it'll hold, it's going to feel a lot more humid. There's going to feel like there's a lot more water in the air, or moisture. So it's going to feel more moist. So that's relative humidity. So they'll tell you, oh, the relative humidity outside is 100%. It's going to feel really, really moist out. Whereas if it's a really hot day, it could still have a higher measure of water vapor. So like 8 grams or 20 grams even, something like that. But it might not feel as bad because it's warm out. So that's dew point, humidity, and relative humidity. And the last thing, we've got this huge space on the bottom. I wanted to draw a picture of the weather cycle, because before, or the water cycle, I'm sorry, we didn't have as much space. So we're going to take care of that right now. Let's start by drawing a little landscape. This is water. And let's just say that this is my underground water. I'm going to put a tree up here too, because, you know, there's a tree, maybe like a house or something. a great house. Whatever. Clouds. Should we say it's raining? And then regular clouds that aren't raining. Okay, so we're gonna label this stuff, and the more obvious ones, I suppose. So let's go right here. We have evaporation. So that's going to go all the way up into the clouds from this body of water. Let's say water. Evaporation. This is going to get, let's say, blown this way by some wind, which I think we even talked about on the last page, wind. So that's going to get blown over here, and then it's starting to rain. So that's called precipitation. So we have precipitation, evaporation, condensation. Oh, forgot condensation. This is the cloud. So it condenses into a cloud, moves over here, condenses so much that it precipitates. And then we've actually got a couple more things we should really add. And we already had this definition. This is runoff, where that water goes over the land. But there's this one other thing where it actually soaks into the ground, and we'll talk about it at some point. But this is called infiltration. So it's going into the ground. That's called infiltration. And this whole thing underground is an aquifer, but it's just groundwater. So, and we've had that word. It's water underground. So that's our basic drawing of the water cycle, sorry. So evaporation, condensation, precipitation, and infiltration is our kind of our new word. That's where it goes into the ground. So that's it for today. Page 7. Maybe we should, we already did that. We already put it on our front as humidity. And that's it. See you guys.